So the identity, the trigonometric identity that relates them is inverse sine of x plus inverse cosine of x is equal to pi over 2, where x is in the interval from -1 to 1. So now let's talk about the fourth and the final method to solve the integral of inverse cosine of x dx from where x goes from -1 to 1. Now in this fourth step, instead of apply integration by parts, the trigonometric substitution, the integration shortcut, which is here the upper part, we will try to use a trigonometric identity. This is I think this is a very special trigonometric identity because it involves the relationship between the inverse cosine of x and inverse sine of x and pi over 2. So the identity, the trigonometric identity that relates them is inverse sine of x plus inverse cosine of x is equal to pi over 2, where x is in the interval from -1 to 1. So here what you can see here is since the lower limit and upper limit of x is in between -1 to +1, we can actually apply this trigonometric identity. So in order to apply this trigonometric identity, we have to express this trigonometric identity in form of inverse cosine of x is equal to some expression. So we can apply this equation, inverse sine of x plus inverse cosine of x is equal to pi over 2. So since this is the trigonometric identity that relates the inverse sine of x, inverse cosine of x pi over 2, then inverse cosine of x is equal to pi over 2 minus inverse sine of x. And then why am I doing that? Why am I doing that? Well, that's because if we plug this expression to here, so this is equal to the integral from -1 to 1 of pi over 2 minus inverse sine of x dx. If we separate the integral and the dx, now I have the integral from -1 to 1 of pi over 2 dx minus the integral from -1 to 1 of inverse sine of x dx. So what does this do? What will these two so I know what to ask me. Why am I apply this identity? Now, well, that's because inverse sine of x is an odd function. When we integrate an odd function from -a to a for all a being positive real numbers, it's going to automatically equal to 0. But if you integrate an even function from -a to a for all positive real numbers, then the integral is going to be the integral of the same even function from 0 to a, and then that integral times 2. So pi over 2 is a constant function, and remember, every constant function is an even function, whereas inverse sine of x is an odd function. So what I can conclude is since the inverse sine of x is an odd function, then the integral of inverse sine of x dx from -1 to 1 is just automatically equal to 0. You don't need to do this anymore. whereas the pi over 2, since pi over 2 is an even function, so this integral is going to be equal to 2 times the integral from 0 to 1 of pi over 2 dx, which is equal to the integral from 0 to 1 of pi dx. And then you use your mind to solve this, you will get actually pi. So this is the fourth method to solve the integral of inverse cosine of x from -1 to 1. And then nevertheless this form, and then no matter we apply the fourth method to solve the integral of inverse cosine dx from -1 to +1, we will still get the same answer. So I think this is very cool, because sometimes you have so many methods to solve just one integral. So this is sometimes it's going to be very fun and challenging. And as always, if you guys enjoy this video, leave a like and subscribe to my channel for more upcoming math videos, and I will see you guys next time.